Hello, my name is Anuradha. In this video, I will briefly introduce how to design and play the Connect 4 game with MATLAB's App Designer. In this game, two players have different colored pieces. The game's objective is to get 4 adjacent or connected pieces of your color. The pieces could be 4 in a row, that is horizontally, 4 in a column, vertically, or 4 in a diagonal. The first player to get 4 consecutive pieces wins the game. There are openings at the top of the game board where you put your chips. The pieces slide down inside the board as far as they can and land on the first available lowest row. The code has an algorithm that emulates this feature, and the first available row for the piece is computed such that it lands in the row just above the row underneath that is filled. The game's strategy is such that the pieces are built from the bottom to the top, and you cannot choose a spot anywhere in the middle. Each player has 21 chips, 21 red for the human player and 21 black for the computer. The standard board is a grid with 6 rows and 7 columns. Forming a winning strategy by using a combination of offensive and defensive play is essential. A good defensive move blocks your opponent from winning, while a good offensive move would be to make winning Connect 4 formations with your chips. It is essential to practice several strategies and tactics to set up a winning scenario in every game you play, although the game sounds reasonably simple. In this game version, the strategy employed by the computer to block you from winning or the computer's winning move is not very advanced, so it is necessary to be wary of these moves by the computer, which will help you win easily. Here we'll discuss briefly some of the winning strategies. This game requires good foresight and anticipation of your opponent's or computer's move so that you don't inadvertently play a move that puts the computer in a winning position. It is also essential to always remember to stay in the middle of the board. Making a move in the central column will make it much more difficult for the computer to connect 4. You must ensure the computer does not get 3 in a row with playable space on either side. It is also essential to avoid game-ending spaces, which might lead to a win for the computer depending on who plays a move there. If this happens, then as soon as such a space is filled, the game is over. So watch out for such spaces and never play directly below the game-ending space. Also be on the lookout for moves that create multiple winning options, such that even if the computer blocks you in one direction, you have another winning option available to finish the game. Another way to create a double win option scenario would be to create a 7 trap. This will create 2 winning Connect 4 slots that are one on top of the other. This way, you can win with the first slot if your opponent doesn't block you. If the opponent blocks you, then you can use the second top slot to win. Before moving ahead, I want to show you something. For the last 28 days, roughly 5.9% of viewers have subscribed to our channel based on our YouTube statistics. If you have not subscribed to our channel yet, we request you to subscribe now. Let us jump back to our video. Let us see how this game is programmed in MATLAB. The 4 public properties used by the code are a variable var to load the board image and chips, result, which is an integer from 0 to 3, 0 for no result, 1 for the player wins, 2 the computer wins, 3 draw. Game board, which is a 6x7 matrix, row, which contains the playable row number, and invalid play, which is a flag set to 1 if the player tries to drop a chip into a column that is already full. If this happens, he will be alerted to try another move. The game parameters are initialized in the startup function, which loads the empty board with red and black chips. The game board is initialized as a matrix of zeros, representing the internal state of the board, and gets updated with 1s and 2s as the game continues. The 1s are filled into the row and column indices of the player's move and 2s for the computer's moves. The red chips are assigned to the player and the computer is assigned the black chips. The game begins with the player's turn. He has 7 columns to choose from and a red chip is dropped into the board on the selection or click of a column. The code which implements this is shown here and consists of the sections that find the lowest available or unoccupied space within that column, place the chip and check the result. The function playerMove takes the column number as the input argument. There is a small pause following the player's move, after which it is the computer's turn to play. This part of the code checks for horizontal win or block options by checking row by row to find 3 in a row by either the player or the computer. If it finds such an option, it stores this option's row and column indices. A similar check is done to find the vertical win or block and the 2 diagonal win or block in these code sections. This is programmed such that the computer prefers the win option first over the block option. It goes through the list of options and chooses the options with win bool of 1 or the last available option. In this part of the code, the computer determines a random column and the lowest unoccupied space if it does not find a win or block option in the current turn. Then the board is updated with a black chip on the selected row and column. After this, the result is checked for a win, lose, or draw by the code in the function checkResult, which takes the game board matrix as an input argument. The checkResult function checks for 4 in a row in the horizontal, vertical, and 2 diagonal directions and sets the result flag. The label on the UI keeps displaying the game's state: computer's turn, player's turn, win, lose, or draw. Once the game is over, a new game can be started by clicking on New Game. Let us go through a demo of this game to see how it is playing. Suppose you pick column number 4 to drop your piece. A red chip is generated and lands in the 6th row and 4th column on clicking on the column number. Then it is the computer's turn to play. The computer is programmed to intelligently find the possible win moves or block moves horizontally, vertically, and diagonally. If it does not find a win or block move on its current turn, it picks a random column and a black chip is placed on the first available row. Then it is the player's turn and he drops a red chip down the 3rd column. So this way the game continues, and after every move is made, the result is checked for a win, loss, or draw. When there is a winner, the game is over. If you want access to the MATLAB codes developed by me, visit the blog with the link in the description and purchase the blog resources. I had also developed a Mastermind game with App Designer in one of my previous blogs. This is the application of Mastermind, and here is a quick look at how the game is being played. I recommend you to read the blog and watch the video to understand and implement the game yourself. You should also check our various webinars or the stock market application course if you wish to advance in the App Designer. Thank you for watching this video. Do like this video if you found this helpful. If you have any queries, please post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future. MATLAB is our future. Happy MATLABing!